pops on a little red button. All right, so this is the Silly Lab, or the Silly Walk Lab, and the Distance Determination Lab. It is two labs in one. And the idea on the Silly Walk Lab is simply this. I'm going to set up a course. Actually, the course is already set up. It's and it'll remain there for you. It's right outside the auditorium. And when you come into the school by the gym auditorium, you'll see there's a carpet there. And from the end of the carpet to the green tape on the floor is 20 meters. So you're going to walk that 3 different times, and you can turn around and walk back, and then you can walk again. So 3 different times in 3 different ways. One may be slow, one medium, one faster, maybe one is skipping, whatever. But just do 3 different walks. You're going to come up with 3 different times. You're going to use your velocity formula. You know the distance is going to be 20 meters, and the time you have on your cell phones, you have the ability to get the time. If not, I have a stopwatch, but you have a cell phone and you can do time on that. Okay, so you use a stopwatch for that. And you will calculate your distance. So write that stuff down. You'll make a quick data table that will handle that. Okay, so that's really quick, gives you some practice doing this. Each one should be very different so that you have 3 different velocities. Cool. Later on, you'll graph that. The next thing you're going to do, when you're done with that, you're going to do this distance then 5 times, and each time you're going to do your best to keep the same velocity. So how do you keep as close to the same velocity as possible? Well, come up with something. Sometimes when people are doing it, they sing to themselves. Sometimes they do a march. 1, 2, 3, 4, go. Boom, 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 boom. Whatever you think would work for you. Now, does it have to be the same velocity? I would like you to try to get the same velocity. Is it possible to get the same velocity? No, of course not. And this gets a little bit to the heart of the matter. What you're really looking for is what is the range of velocities you got when you were trying to keep it the same? Because there's not going to be a single number, and an average is a lie. If you are telling me I average 1.12 meters per second, okay, but at one time you might have gone 0.8 meters per second, and another time you might have gone 0.3 something meters per second, and you simply got an average. What I want is what's the greatest velocity you had, what's the least velocity you had, and so what you're trying to do here is make the smallest range you can get. Now, do I care how big your range is? Would I ever grade you on your range? No. What I want you to see is that you have a range, because this is another way of thinking about numbers. Instead of average, you find out what you're really doing, right? Some people are able to do this over and over, almost exactly. It's freaky how some people can do it so perfect. I don't care. I could do it pretty good. I suspect some of you do it better than me. I suspect some of you do it worse than me. Don't really care. What I care about is what's your range. Okay, so once you have that, you now have done it 5 times. You can do more if you need. Drop out anything that is completely ridiculous, right? If you find a better way to do it, do 4 more that you're going to use for this. This is not a big deal. All I'm looking for is a range. All right? Now, once you're done with that, that's lab number 1. We're combining labs 1 and 2 so we can do them kind of faster. And they both get to the same idea. This is a new way of thinking about numbers. This is how physics thinks about numbers. We want a little bit more honesty than you've ever done in a class before. This gets to the engineering of numbers. Way down the hallway, just before you get to the library, on the right side of the hallway, you'll see 3 green pieces of tape together. For lab number 2, you are now going to rearrange this formula, because now you know roughly what your velocity is. With your stopwatch, you can measure time, so you're now solving for distance. And how would you solve for distance? Well, multiply both sides by time, So distance is going to be velocity times time. So when you're all done with the first lab, you've gotten your range, and you might only get your first lab done in the period of time we have, that's fine. But some other time when you have your own time, what you're going to do is you're going to walk. Now when you get to the 20-meter mark, and you're trying to maintain the same velocity that you had gotten, so you were like good at being a velocity machine, when you get to that 20-meter mark, on your stopwatch, you almost certainly have a lap timer, so you just press the lap. And you'll see, is it close to the same time you had before? If it's wildly different, maybe you want to stop and go back and try to get so it's closer. So you can check yourself there by using the lap timer. It doesn't stop your stopwatch. Just as you're walking, you get to see how you're doing. Cool. Now, you're not measuring the distance. I mean, you are in this lab, but do we care about the distance? No, we care about the process. So we're worried about the process. So you're now going to go check your lap time and keep doing that same constant velocity till you get here, in which case you stop your stopwatch. That's your time. Make sure I'm on that. All right? So then you're going to turn around and you're going to come back. Then you're going to turn around and go again. And you're going to do this, I don't know, how many times till you think you might have done it well? You figure probably 3 or 4 times. Okay? Not to go too crazy. But at the end of this, on lab number 2, the last thing you're going to do is tell me the range of possible lengths of the unknown distance. So you're not going to tell me a distance. Rather, you're going to say it's maybe from 60 meters to 73 meters. Now, that's a big range. But that might be what your numbers are telling you. Now, how would you get that range? You know your velocity range. You might have 0.92 meters per second, and you might go up to 1.07 meters per second. Whatever you get is fine, but you know your range of possible velocities. Then you will know the times you did for this, and you might have 63.4 seconds to 68.2 seconds, something like that, right? And you might have a closer time, you might have a farther time. Don't care. Which of these numbers, when multiplied, would give you the smallest possible distance? What do you think?
63.4.
Right? Would give you the shortest possible distance. So that would be the lowest part of your range. This number, your higher velocity times your longer time, would give you the longest possible range. This number. So this is not statistics. This is not how you would best determine this. I don't care about that. Because this is the first time you're really thinking that it's not a single number. It's a range of numbers. Now, if you do this right, should the actual hallway length fall within your range? It actually should. And it usually does. And if it doesn't, okay. It's not to measure the hallway. It's to give you a different understanding of how we do this. Okay? That's what we're doing. So you have this. I'm going to give you clipboards. And you have something to write with. You have your phone and you have a calculator. Do you have your calculator? Cool. And that's what we need. All right?
Can we just use the calculator on here?
Yeah, any calculator, because super simple calculation.
Yeah.
Yep. All right. You can stop the video because we are good.